We're now going to walk through 3 antiderivative examples where we're given a second or a third derivative and we want to find the original function. In all 3 of these examples, we're going to find the function little f of x. In our first example, we're given that the second derivative of little f of x is equal to 2 plus x cubed plus x to the 6th. We are first going to need to find f prime of x because f prime of x is the antiderivative of f double prime of x. And then we can find f of x because that's the antiderivative of f prime of x. Our first antiderivative is f prime of x, and that's the antiderivative of f double prime, and we can write that down. The antiderivative of 2 is 2x, and then the antiderivative of x cubed, we're going to add 1 to our exponent, so this becomes x to the 4, and then we divide by whatever we get in that exponent. And then our next function, we have a 6 in the exponent. So for this, we're going to have x to the 6 plus 1, which is 7, divided by 7. And then we can't forget to add on our constant c. Now we can find f of x. It is the antiderivative of f prime. And we're going to get 2. And then think of the exponent of x being equal to 1. So we're going to add 1 to that. So this becomes x squared over 2. And then we get an x. We had a 4. Now we're going to get a 5. So x to the 5th over 4 times 5. And then our next exponent is a 7. So we get plus x to the 8 divided by 7 times 8. Plus c, that gets an x added onto it because the antiderivative of a constant is a constant times x. And then we have to add on another constant, and we're going to call that d. Now all we have to do is just simplify our answer. F of x is equal to x squared, our 2's cancel, plus x to the 5th over 20, plus x to the 8th all over 56, plus cx plus d. And there's our answer. In our next example, we are given that f double prime of x is 20x cubed plus 12x squared plus 4, and we're also given that f of 0 is equal to 8 and f of 1 is equal to 5. This type of example is called a boundary value problem because we're given the values of the function at 0 and at 1. I'm going to write a diagram just to make this a little bit more clear. We'll label this as x, and then we'll put down x is 0 and x is 1. And at 0, we have our function equal to 8, and at 1, it's equal to 5. And that's why it's called a boundary value problem, because we're given the function value at our boundary points 0 and 1. Let's start by finding f prime of x. F prime is the antiderivative of f double prime, and this gives us 20. We have an x cubed, and we're going to add 1 to that, so this becomes x to the 4 over 4. And then we have 12. We now have an x squared, and we're going to add 1, so this becomes x cubed over 3. And then whenever we have a constant, we have to tack on an x, and then we also have to add a plus c. Before we go on to find f of x, let's go ahead and let's simplify this. F prime of x is equal to 20 divided by 4, which is 5. 5x to the 4th plus 4x cubed plus 4x plus c. You always want to simplify before you take an antiderivative again. Now let's go ahead and find f of x. It's the antiderivative of f prime of x. And this is going to be 5x to the 5. We're just adding 1 to 4 divided by 5 plus 4x to the 3 plus 1, which is 4, divided by 4, plus 4x, think about that as a 1. We're going to add 1 to that, so 1 plus 1 is 2, so we have an x squared over 2. And now we're going to have a cx plus an additional constant because we took another antiderivative, and we're going to call that d. Now let's go ahead and simplify again. F of x is equal to x to the 5th plus x to the 4th plus 2x squared plus cx plus d. Notice that in this answer, we have two constants, c and d. We can eliminate those two constants using our two boundary conditions. F of 0 is equal to 8 and f of 1 is equal to 5. The first thing that we're going to do is to let x be equal to 0. So we have f of 0. That is just equal to d, so that's really nice. And that's going to be equal to 8 because we were given that f of 0 is 8. Now let's find f at 1. All we do is go back right up into this equation. Let me go ahead and let's highlight this. And we're going to substitute x as 1. So this gives us 1 plus 1 plus 2 plus c plus d. And that, looking back up to our original problem, is equal to 5. This gives us 2 plus 2, so this is 4, plus c plus d. We know that d is 8, so let's put that in, is equal to 5. So we have c plus 12 is equal to 5, and that gives us that c is equal to minus 7. Let's highlight here that d is 8 and c is minus 7 because we now have to substitute those back in to our function. Our answer is f of x is equal to x to the 5th plus x to the 4th plus 2x squared minus 7x plus 8. And that's our answer. One nice way to check this answer is to let f be equal to 0 and then 1 and make sure that you get 8 and 5. And then you can check it even further by taking two derivatives, and you can see that you get 20x cubed plus 12x squared plus 4. In our third example, we are given that f triple prime of t is equal to sine t, and we're also given that f of 0 is 1, f prime of 0 is 1, and then f double prime of 0 is also 1. This is an example of an initial value problem because we're given the value of the function and its derivatives at time t is equal to 0. Let's start by writing down our function. F triple prime of t is equal to sine of t. To find f of t, we first have to find f double prime of t and then f prime of t, and then we can find f of t. So let's find f double prime of t first. That is the antiderivative of sine t. The antiderivative of sine t is minus cosine t. And we add on a plus c. Now let's find f prime of t. It's going to be equal to minus the antiderivative of cosine t. That is sine t. And then with our c, we have to multiply it by t. And then we have to add another constant because we just did another antiderivative. And we're going to call that constant d. F of t is equal to minus the antiderivative of sine t. That is minus cosine t. We did that earlier. Plus c. And then the antiderivative of t, we're going to add 1 to the exponent. Think of that as a 1. And then divide by that number. So that's dividing by 2. And then we have a d times t. And we have to add one more constant, and that is e. One thing to keep in mind is if you are given a third derivative, when you find your original function, you are going to have 3 constants. The number of constants that you get is equal to the number of derivatives that you start out with. Now let's go ahead and let's simplify this. We have f of t is equal to cosine t plus 1/2 c t squared plus dt plus e. Now what we want to do is we want to find c, d, and e. And to do that, we are going to use the three conditions that were given up here in our original problem. Let's start with f double prime at 0. Let me go up and highlight this so you can see where we are looking. We are looking right here. If we let t be equal to 0, we get minus cosine 0 plus c. Cosine of 0 is 1, so this is minus 1 plus c, and we set it equal to 1 because that's what we were given in our original problem. And this tells us that c is equal to 2. Now let's look at f prime at 0. Let's go ahead and highlight that now. That is right here. So we're going to let t be equal to 0. This gives us minus sine of 0 plus c times 0 plus d. Sine of 0 is 0, so this is just d, and it is equal to 1 because that's what we were given originally. Now let's look at f at 0. That is right here. We're going to let t be equal to 0, so this is cosine 0 plus 1/2 c times 0 plus d times 0 plus e. Cosine of 0 is 1, so this is 1 plus e, and this is equal to 1. Again, back up in the original problem, we were told that f of 0 is 1, so this tells us that e is equal to 0. Now that we know c, d, and e, we can write down our answer. F at t is equal to cosine t plus 1/2 times c, which is 2, t squared, plus d, which is 1, times t, plus e, which is 0. So our final answer looks like this. It's cosine t plus t squared plus t. The biggest mistake I see students make when doing this type of problem is forgetting to add on a constant every time you find an antiderivative. So just make sure to do that.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.